Hello, everyone. So before we get properly started, at this URL and this QR code, you can get the slides for the presentation, which, if you're planning to follow along, I highly recommend. There's some links in there. And who all is planning to follow along with the presentation? OK, a whole bunch of people. That's awesome. If you do not already have the things over here on slide number 10 installed on your system, you should start doing that. There's like an introductory portion, so if you can try and get all of those things in place before we start, that would be awesome. If you are on Windows, I recommend MSys2, although use whatever you're comfortable with. Like if you use Visual Studio normally, like definitely use that. But if you have no preference, MSys2 gives you like a Linux-ish terminal environment, and you can install almost everything you need with that first command, that pacman-s. And then after that's done, you can run this Python mpip install scons to get scons. And then you'll have everything you need. I'm going to be doing this on Linux. So I'm going to be doing things in the terminal. You'll be able to enter all of the same commands on Windows if you're doing that. If you are on Mac OS, I'm afraid you're on your own. I don't know anything about Mac OS. But probably something with Homebrew will be able to get you the compilers and Python and all of that stuff. All right, and I'll put this up here again, just in case anyone hasn't managed to get it. All right, I am David Snopek. I am a Godot maintainer on the XR and GDExtension teams. I maintain or co-maintain various open source Godot add-ons and extensions. Probably the most well-known is the Godot Rollback Netcode add-on. The SG Physics 2D extension is a deterministic physics engine for Godot to pair with the rollback netcode, which needs determinism. And the Godot OpenXR vendors extension, which I talked about a bunch at my presentation last night. And more. I work for W4 Games, and I also make my own silly little games and tutorials, which you can learn more about at snopekgames.com. That's me. Who are you? This presentation is geared towards folks who have like an intermediate level of C++, an intermediate level of Godot, but who have never done both C++ and Godot together before. So if that's you, this talk is for you. Unfortunately, this is kind of like a beginner, well, not unfortunately, I mean, it depends on what you're looking for, but this is kind of a beginner GDExtension talk. If you're looking for something more advanced, like digging really deep into how GDExtension works, that would be an awesome presentation, but that's not what this is. So this is geared at folks who want to integrate a third-party library with Godot, so like a C or C++ library that you want to integrate into your game, to extend Godot without modifying Godot's source code, to script your game logic in C++, or to get native performance for some select parts of your game. So those sort of use cases. What is GDExtension? So it's a C interface that allows you to interact with the internals of Godot, including adding new native classes, like making your own native nodes, resources, or objects, adding editor plugins, adding new scripting languages. So there's GDScript. You can add a new scripting language that you can attach script to another node. And in the future, probably the near future, embedding Godot inside of other applications. There's a PR from Migron. We discussed it at the sprint a couple of days ago. It seems like there is general consensus from the maintainers that this is a good idea. So yeah, very likely Godot 4.4, that will be an option as well. Language bindings is something that comes up a lot when talking about GDExtension. Language bindings adapt the C interface of GDExtension to make it easy to use from a particular programming language or environment. So for example, godot-cpp binds GDExtension to C++. We're going to be talking a lot about godot-cpp. Or Godot Rust binds GDExtension to Rust, Godot Swift to Swift, Godot Go to Golang. There are a ton of GDExtension bindings. Probably most programming languages you could think of have a GDExtension binding for Godot. Quick note, language bindings are not the same as a GDExtension that adds a scripting language. So there are GDExtensions that add for example, the ability to attach scripts written in Luau to your nodes. You can make a GD extension that adds a scripting language. You can even have a language binding that also allows you to add scripts, but there is a little bit of a difference here. We're going to be mostly looking at adding new native classes to Godot, which is different than having a new scripting language. So that like the native classes that we create, you'll be able to put that node in the scene tree and additionally attach a GDScript to it. So I just want to make that clear. What is godot-cpp? So it's the official GD extension binding for C++. It's the only official GD extension binding. All the rest are maintained by the community. However, there are really a lot of ways to design a language binding. A lot of different ways you could approach exposing the API to developers. So, what makes godot-cpp? What is its core design goal? It aims to provide the same API as used within Godot itself. So internally, Godot is composed of modules, which you can enable or disable. And the idea of godot-cpp is that you have the same API to make your GD extension as you would use internally in the engine itself. And that design decision ends up driving a whole ton of other stuff about godot-cpp. I could imagine someday someone making a new C++ binding that doesn't have this goal and aims more for doing the newest C++ stuff, making it as easy as possible to write a small amount of code to do all of the bindings and all of that. But that is not what godot-cpp is. But I think it's very interesting having this design goal. It means everything you learn today will be things that you could take to become contributors to the game engine itself. So all of the code we're writing is stuff that you could go right into the engine. So you additionally get that ability. And I should note that it isn't 100% API compatible. There are some small differences. We are getting there more and more. Probably it's not going to be possible to get to fully 100%, but it's really, really close. And you can write a single code base that can be compiled as a module within Godot or as a dynamically loaded GD extension, and you work around a little bit of API differences with if-defs. So basically, if-def GD extension, slight API difference over here, else how it is in the actual Godot. All right, so what are we going to do today? So it's a workshop, and we're going to write code, and you can follow along if you want to. If you don't follow along on your laptop, I think it should still be interesting, I hope. And the things that we're going to cover in 5 parts, we're going to talk very briefly about the requirements you need to have installed. Hopefully you have those already, or you got them during the introduction bit there. We are going to set up a basic godot-cpp project, and then we're going to do kind of 3 examples. The first example, we're going to create the simplest possible GD extension class just to get started. Then we're going to do a simulation of the use case that you want to extend the engine. So you're going to make a reusable GD extension that you're going to put up on GitHub and people are going to download and use in their projects. And then the final example, we are going to simulate using GD extension to develop your game logic. There isn't really any technical difference between those 2 use cases. You can absolutely have a GD extension that extends the engine and does game scripting, but the kind of things you'll use, the kind of features of GD extension, the features of godot-cpp will be a little bit different. And usually people do one or the other, so that's kind of why we're looking at them as separate things. And the full source code that we're going to be writing today can be found at this project on GitHub. So yeah, any questions so far? In general, if anyone has a question, just shout it out. Definitely it's better to address any confusion when it happens rather than just kind of plowing on forward. If you're uncomfortable shouting things out, I guess you're a very polite person. You can raise your hand. I can't guarantee that I'll see you, though, so I'm going to be typing code and stuff. So it's OK to shout things out. All right. So we're going to be using Godot 4.3. You'll need a C++ compiler. Any C++ compiler should work, GCC, Clang, or MSVC. Like I said, on Windows, I recommend MSys. And if you choose to use MSys, you can run this command to install almost all of the things. You'll need a Git client. We're going to be using Patrick's godot-cpp template, the official godot-cpp template to be the base of our project. You'll need Python because we use the scans build system, which is based on Python. and you can run this command. This command should work on any system, as long as you have Python installed in order to get scans. So I'll leave this here for a couple more seconds. All right, so to get started, we're going to go to the godot-cpp template project. It's github.com/godot-engine/godot-cpp-templates. If you have the slides, there is that link in there. And we're going to use this friendly use this template button. We're going to create a new repository. And I'm going to call that GodotCon 2024 GDExtension. And it's going to clone that template into a new repository under my personal organization, the organization of me on GitHub. All right, and then I'm going to grab the SSH URL in order to clone this repository. I'm going to go to my command line. Ooh, it gets really dark when I... Oh. I'm going to do git clone and then -- recursive. The -- recursive is important because that will pull in the git submodule that has godot-cpp. If you forget it, it's easy to fix afterwards, but that is why we're adding it here. And then the URL to our repository. All right, and then we're going to open up, ooh, I didn't mean to put this here, though. Let me move this to the directory I usually keep projects in. And then open up that directory in your code editor of choice. I'm going to use VS Code. And we're going to take a look at the files that you end up with. So we've got godot-cpp in this directory here. If yours is empty, that means you forgot to add that recursive. And if you need to work around that, the command that you need to run is git submodule init recursive. Oop, maybe not. Git submodule update init recursive. There we go. And it doesn't do anything for me because I did do the recursive, but if you forgot it, that is the command to run. All right, we've got this source directory, which, no, not the source directory in godot-cpp, the source directory at the top level, which is going to have the source code for your GD extension. It starts out with just these two files, register type CPP and register types H. We're going to be doing most of our work here within this source directory. There's a demo directory, which has a Godot project. So if you're making a GD extension that you're going to distribute to users online, like on GitHub, you could put a demo project here that shows how to use it. If you're going to script your whole game in GDExtension, you could rename this to game and have that be where your actual game is. We are using the scans build system, and that is configured through this sconstruct file at the top level. It includes the configuration that comes from godot-cpp and just kind of uses it in order to build our project. We're going to have to rename a few things in here for our extension. For example, this extension-name, I'm going to rename that to GodotCon 2024. And this projector that's pointing at the demo, like if you did rename that to game, you would also have to change this to be game. And this controls what the name of the output library is that gets built. So this will end up with a GodotCon 2024.template_debug.dll, something like that. We need to make that same rename in a couple other places, so I'm just going to search the whole project for extension-name, and we don't care about the README. There's a couple of these files here, these .plist files, which are for macOS. I don't entirely know what they're for. I just know that you need to rename this so that it matches the name of the output library. But the thing that is most important here is the .GDExtension file. So this file is what Godot uses to know how to load your GD extension. There's a list of all of the libraries for all of the different platforms. So for example, we have Linux.debug.x86. This is telling Godot to load this particular shared library. If you are on Linux in a debug situation, which is either in the editor or, in the editor if you're running a debug version, and on x86-64 processors. We also have Linux release x86-64, Linux debug for ARM64, Linux release for ARM64, and so on. So we need to replace all of these with GodotCon 2024. I'm just going to use the search and replace, which will get it in this .GDExtension file, and these plist files. All right, and there's one more thing we need to rename in here. This entry symbol. This is a function within your GD extension that Godot will call that will allow your GD extension to get initialized. It is set now to example library init. On some platforms, you cannot have conflicting entry point names. On some platforms, it will work, but we're gonna follow the rules here, and we're gonna actually rename it. I'm gonna call that GodotCon 2024 _ library _ init. And we've renamed it in here. We also need to rename it in the code. So this is within the register types.cpp file. This function down here is the entry point. And we rename it from example library init to GodotCon 2024 library init. And you mostly don't need to worry about the code in here. This is doing kind of the standard steps to initialize godot-cpp. The only thing I'm going to point out is you register an initializer function. We're registering initialize GD extension types and a terminator, which is uninitialized GD extension types, which are defined up here. So we're going to be registering a bunch of stuff in the initialized GD extension types. I don't think in this workshop we need to explicitly uninitialize anything. But if you did need to uninitialize something when your GD extension is unloaded or reloaded, you would do it here in this function. All right, I think that's everything we need for this to actually compile and work. So we're going to get this started building right away, because it might take a little while. On my system, actually, let me say what I'm doing before I do it. On my system, it takes like 4 minutes. So we're going to get it compiling, and then we'll start writing code for the next part while it's going. And to compile, you just type scons in the top level directory of your project. I need to make this bigger. Yeah, there we go. Ooh, maybe too much. Can you guys read that? Is that good? Awesome. All right, so we just need to run the scons command and let it go. All right. So the first example we're going to do is the summator, or summator? Yeah. I sometimes say summator, which sounds really weird. Summator makes more sense. We're going to do this example. We're going to create a simple class that just adds numbers together. This is the same example that's in the Godot documentation. So to do that, we're going to create a summator.h file underneath the source directory. Pragma once. It is going to be a child class of object, so we need to include the header file for object. That's godot_cpp classes object HPP. VS Code. Okay, so we need to tell VS Code where to find the header files so that it doesn't complain like this. If you're using a different IDE, you'll need to do it however that works for your particular IDE. In VS Code, we're just going to configure that really quick. It's very simple. If we go to the C++ configuration, we're not using Clang. We are using G++11. IntelliSense, not Clang. We're using Linux, GCC, x64, and the include path. So the godot-cpp headers that we care about are under your workspace folder /godot-cpp /gen include, and then I think there's also an include directory that we need to get. Include, I think that's right. I'll double check right now. godot-cpp, yep, include. And the way godot-cpp works is quite a lot of it is automatically generated. So the handwritten stuff is under this include directory, and the generated stuff is under this gen include directory. All right, that should make VS Code happy. Yay, no more little squiggles. All right, we'll add using namespace Godot. All of the classes in godot-cpp are in the Godot namespace. That's different than within the engine itself. They're not in any namespace within Godot. And our summator class is going to extend from the object class. And we have to use this special macro, which adds a bunch of like registration code to the class for us that Godot needs, which is GDClass. And we give the name of the class, summator, and its parent class. And because we're going to be adding numbers together, we need a private variable to keep track of our count. We're going to add this protected static void bind methods function. This is a kind of magic Godot function that you're going to need to put on all of your classes that you're binding to Godot. We'll look more at that in a little bit. And then some public functions. We're going to have a void add, which takes an integer, void reset to reset the value, and a function that returns the current total, and a constructor. And why is VS Code unhappy? Oh, there we go. All right, now we're going to add the implementations for all of these methods in a summator.cpp file. So first we'll need to include the summator.h. And then this is my personal way of creating the functions in the CPP file. There's probably a VS Code plugin I could use, but I copy the ones from the header and then add that. So here we're going to just kind of get the boilerplate in place for all of our methods and then implement them. So add is going to add to our count. Reset's going to set our count to 0. Get total is going to return our count. And then our constructor is just going to set count to 0 as well. All right, so that's all of the functional code in our summator class. Now we need to implement that magic bind methods function, which will tell Godot about all of these individual methods. All right, to bind a method, we do class db : bind method, bind method, and then we use this d method macro, give the name of the method, the name that's actually going to be used on the Godot side. So you can have a difference between the names of the methods within your C++ and what Godot will see, but don't do that. That's weird. And then you have to give the arguments to the method. So this has one argument, value, and then a pointer to the method itself. So summator add. Oh, yes, thank you, VS Code. I did forget to include the header for class DB. Let's include core classdb.hpp. And that should make VS Code happy. Maybe I have to edit the line. We're just going to keep going and hope either VS Code is wrong or the compiler will give us a better error later. Because classdb is included. Interesting. The joy of live demos, live workshops. All right, so we're going to bind the rest of the methods. Oh, there we go. VS Code's happy now. All right, so this should be everything we need to do in this particular class. We just need to tell Godot about the class. That's something we do over in register_types.cpp. There's a little example here. We need to use this GDRegister_class macro with the name of our class. And we, of course, need to include the header file with our class. All right. Looks like it finished compiling for me. Hopefully it also finished compiling for you. We are going to recompile it with the changes we just made. rebuilt register types, summator CPP, and the library itself. And we're ready to open this in Godot and see if it worked. So I'm going to open Godot 4.3 with the path of our demo project, the editor. I'm doing it from the command line. It's no different from going to the project manager and opening the file and navigating through the file selector there. All right, we're going to make a very simple project. We're going to add a 2D scene named main. I will save it. We're going to attach a script. Main.gd is fine. And within the ready function, we're going to use our summator class. First, we'll create an instance of it. Do var summator equals summator.new. Okay, so Godot should see it in the autocomplete. There is a bug in Godot 4.3. It's already fixed in master. It will definitely be fixed in Godot 4.4, but we may also get it into Godot 4.3.1 or Godot 4.3.2, where when you add a GDExtension to your project and open it in the editor, the first time, it won't see it. You have to reopen the project in the editor, and then everything will be fine. So that's what we're going to do. We're going to go to Project, reload current project. And now the autocomplete should know about the summator class. There we go. All right, we're going to use it to add a couple of numbers together. How about 3 and 4? And then print out the total. And you can see it's able to autocomplete all of the methods that we added to it. Let's just run that. Using the current scene. There's nothing in our game window, but we can see in the output in the editor, it printed out 7. So our very simple GDExtension summator class is working. All right, we'll go on to a more complex example. So this is, unfortunately, a kind of artificial example. It's very hard to come up with examples that are simple enough for a workshop, but allow me to show all of the things that I want to show you guys. We are going to simulate extending the engine to make like a reusable GDExtension by creating a traffic light control. So control that shows red light, yellow light, green light. And we're going to imagine that lots of people want to be able to reuse this in all of their projects without creating it themselves. But just to make it distinct from, this is not something we're pretending is just for our game. We're pretending this is a reusable thing that lots of people want. Because, of course, who doesn't want a traffic light? All right. So to get started creating that, we're going to create a header file again, trafficlight.h, do our pragma once. It's going to extend control, so we need to include the header for that. Light extends public control. Oh, and I forgot the using namespace. All right. We have to add our GD class macro again. Name of the class and its parent class. So I have notes on what I'm supposed to do. I can't remember what I'm doing without having like the slides to look at. This is my version of the slides. All right, so we're going to use a texture rect to display the traffic light, the actual visual of it, which we'll need to include that. Texture rect.hpp. And make the constructor all right, let's just connect this stuff together for now. We'll make our trafficlight.hpp. I just realized I forgot something in here. We also need, like I said before, all the classes that have bindings need to have a protected static void bind methods function. Nope, not CPP. H. All right, so we are going to have the texture rect. We need to initialize it, and we are going to use this special mem new macro. I think it's a macro. Might be a function. In any case, we're using it. You cannot use the normal C++ new operator with godot-cpp, and also within the engine. It uses a special allocator and does some special initialization that's needed for Godot. And in fact, I think in the latest version of godot-cpp, if you tried to use the new operator, your Godot would crash and print out a message yelling at you that you need to use the memnew function. We're going to add that as a child to our control, and we're going to set the layout preset, or whatever that function is called. Set preset layout. We are going to not do that right away. Actually, you know what? I will. What I would do in real life, honestly, is I would go look at the source code for control and try and find what this function is called. Set anchors preset. There we go. Preset full rect. So we want it to take up the entirety of our control. All right, we're going to want to have some textures for the different lights that we're going to show. Those are going to be texture 2Ds. And for anything that descends from the ref counted class, that's all the resources, but some other things, you need to use with this special ref template. It manages all of the ref counting. Otherwise, if you don't use it, you will have a memory leak. So we're going to have our go texture, our stop texture, and our caution texture. And then we'll need some setters and getters for those. And the same thing for all of them. And then we can use the getters and setters to create a property that will be visible in the inspector. We have a little bit of boilerplate before we can get there, though. So I know it's not super thrilling to watch me type, but I imagine you are all typing as well, so we'll so set the go texture. Maybe I'll just type it. All right, now we need to bind those methods, same as we did before. which again, it takes the method name that Godot is going to see and the argument name that Godot is going to see, and then a function pointer. Let's what did I do wrong then? Oh, I got the double, a whole bunch of those. Okay, VS Code is happy. All right, now to the new thing. We are going to register properties for each of these, which I always forget the exact syntax to do this. So it's add property, property info. See if I can get the hint from here. Yes, this one. All right, so we need to give the type of the property. In this case, it's our variant. It's a object. The name for the property, so we're going to have a Go texture. Property hint. This is where you can give some extra information about your property. It's similar to like in GDScript, you have the different annotations. Like there's the at export annotation, but you can also do like at export range. I forget those also too, but all those different annotations and the properties you can give them, that's basically what we're doing right here with the property info. And this is a resource, and we give the name of the resource, texture2D. So then this way, in the inspector, it'll know that it wants to have a texture2D in that property, so it won't let you drop other resources in there. And you give the setter, which in this case is set go texture and get go texture. All right, then we need to repeat this for each of those properties. All right, we should be able to compile this and see it in the editor. So we're going to run scans again from the command line. Ooh, some errors. Here we go. Class traffic light defined here. Oh, okay, we definitely forgot one step. I don't know what this error is about, though. Let's take a look at this. Include traffic light.age. Frequently going to see whatever the first error was is the best. Okay, so in static member function, traffic light is not a member of traffic light. Including traffic light.age. That could be. The little black dot has gotten me again. Thank you. There we go. All right. Let's open that up in Godot 4.3 again. And we're going to add a new child node here. Oh, we did forget something, though. I remembered it, and then I forgot it. We need to add something to register types to tell Godot about this class at all. Of course, need to include it as well. All right. I'm going to close Godot. I'm going to recompile with the scans command. And start Godot again. All right, we're going to add a child node, and hopefully it sees our traffic light. There we go. Our new traffic light control. We are going to make it use full rect as well. And if we look at it in the inspector, we have our three properties: the go texture, stop texture, and caution texture. In the slides, there is a link to a zip file which has the three textures that I'm going to use. So download this. And I'm going to extract that zip file. So in the demo project, or in the demo folder, I'm going to make a new folder called assets. And I'm going to unzip that zip file. Where did I put Godot? Here it is. So in here we have the assets folder and our different textures. So I'm just drag those. Where did my inspector? There we go. All right, so now we need to have those actually get shown. We're going to add a property that lets you set the state of the traffic light, and then it'll choose which texture it is going to show. So we'll go back to VS Code. And to do that, we're going to make an enum and register that with Godot as well. We'll call it traffic. Yes? Mm-hmm. Mm-hmm. Yeah, so you absolutely can make a custom icon. The not using the parents icon, I'm pretty sure there's a PR for that already. It may even already been fixed. But yeah, that's a bug, and it either is fixed or will be fixed. Traffic light type, we'll call it. We'll say traffic light go, traffic light stop, traffic light caution, and then we use the macro variant enum cast to allow casting it to and from variants, something we need to do in order to register it. Traffic light type. Not, okay, there we go. And also in the CPP file, I'll make some more room here. In bind methods, we need to register its values. So let's bind enum constant. All right, we're going to add a new variable within the class, traffic light type, say light type. Add a new setter and getter. Do the implementations for those. Which are very simple. And register those. Register our property. This time it's an integer. Light type. We're going to use property hint enum. And this is where we give some friendly names to the enum values, which I think I did them in the order go, stop, caution. Let me double check that. Yes, go, stop, caution. All right, that should be enough to have the property. We still need to make it do something. So we're going to implement another magic godot-cpp Godot function underscore notification so that we can have something happen when the node is ready. It's also possible to implement the underscore ready function. That would work. However, when I'm making like an extension to Godot, I always do it with the notification method because there is a sort of conflict between the underscore ready method from the native class and a script. So like if I used underscore ready and then attached a GDScript to it, the underscore ready from the GDScript would override the underscore ready from my class. So we do it this way with notification, which is also the way that all of the nodes within Godot itself do it. So when we're doing these kind of extending the engine type use cases, we mimic what the engine does. When we're doing like game logic, then yeah, using underscore ready there is perfectly fine because you're kind of doing something more script-like. All right, we'll have a switch on the value we get to the notification function, and we'll do notification ready. So this is, yeah, the equivalent of implementing underscore ready. And let's think, how should we do this? How about we will have the set light type setter is actually going to also set on our TextDirect, set texture. And yeah, well, sorry, I'm going kind of in circles. I probably should have done this first and then did the notification part second. But in our set light type setter here, we're going to switch on the light type we get. And we're going to use that to set the actual texture within the TextDirect. And then we'll use our Go texture when we have the Go in them, when we get past light stop. All right, and then in our ready function, we're just going to call that setter again with whatever the current light type is. So when the node first gets created, it will use the default. Did we set a default? I don't think we did. We will in the constructor. We'll do the default light type will be stop. All right, I'm in the wrong directory. But back in the top level directory, if you're on scans again, rebuild our GDExtension. Open it up in Godot again. And it did not work. I'm wondering if it's because the size is shrunk down. Let's see if that works. Container sizing. Oh, here we go, size. Let's just set it, I don't know, 500 by 500. And we don't see anything. Oh my gosh, live debugging. Oh, caution worked. Now it's working? Oh, that's weird. I'm just going to reopen Godot. When in doubt, turn it off and turn it on again. Seems to be working now. In any case, note how when we change the property value in the editor, it's also changing it live here, just like as if you had done like a tool script in GDScript, if you used the @ tool annotation. By default, all classes registered with GDExtension will be like tool classes. They'll run both in the editor and in your game. This is the exact same as classes created within the engine itself. All right, so like how native classes can have virtual methods like _ready and _process, you can also declare your own virtual methods within GDExtension. So we are going to make one of those. Yes, we're going to make a showNextLight method that calls to a getNextLight virtual method that you can put in a script attached to this node. So in our imaginary universe where users actually want this, they can customize the order of the lights. So I'll add our showNextLight method. So the question was, doesn't it have to be virtual? So we're making a Godot virtual method, which is like a separate thing that's like registered in ClassDB. If you were doing a thing where you had a hierarchy of classes within your GDExtension, and some of those classes like overrided that virtual method, and then you like also wanted scripts in Godot to override it, like yeah, you would make it be virtual so that it could kind of work in both places. It could be virtual in C++ and be virtual in Godot. We're not doing that here. I guess to sort of simulate that, we can make it be virtual. Doesn't have an effect for what we're doing though. All right, and we also need to declare the virtual method. I always forget the exact name of these macros. Is it just GD virtual? And it will take one argument, because we're going to pass it the current light type, and it's going to have a return value. So we do 1 for the number of arguments, R for return value, and C because it is const. And we're going to call it getNextLight. What did I mess up? Oh, I have to tell the return value. And I put that before it. So is VS Code going to be happy? No, it's not. Oh, yeah, and we're taking an I'm sorry, guys. So we're taking one argument that's an int. We're returning a value which is also an int. And I think this is right. What am I doing wrong? Here's what we'll do. Let's go look at. I have the full repo built out for this whole project. We'll take a look at what I did there. GD virtual 1RC. Oh, okay, the enum types. But otherwise, I think it should still have worked even with ints. GD virtual 1. Oh, I bet I have to include something I didn't include. Core GD virtuals. There we go. I think this has all of the GD virtual macros. Okay. And we're going to use our enums here instead of int. All right, so GD virtual, the number of arguments, we add an R because that is a return value, and C because it's const. You could also have had a number of other permutations of this. You could have just GD virtual that just took an argument, didn't have a return value. You can have a return value and not const, or the full thing. And we also need to register that over here in the bind methods. And I think that's, is it bind virtual method? I think that's the right one. Or not. I'm sorry, guys. I do not ever keep these things straight. What I end up doing usually is looking through the Godot source code or previous GD extensions that I did to, okay, GD virtual bind is the right macro. All right. And then we're going to have our show next light function actually call that, that virtual method. So we need to declare a variable to hold the return value. So that'll be light, traffic light type. So it'll be next type. And then we are going to put this in an if statement. This will return false if the virtual method was not overridden. So do GD virtual call, and we're going to call get next light. And I think the order of arguments we do is the argument that's being passed to it, and then the return value at the end. And then we will set the light type to what we get back for next type. I think that is correct. Cross your fingers. We're going to run scans. And I got something wrong. The errors kind of make me think that I forgot to put this variant enum cast, but I did do the variant enum cast. Cast. Register all of the types up here. We'll fall back on the old reliable of what's happening in the working project. I put it up there. That shouldn't make a difference. I'm sorry. That I didn't put the argument on there. Are you saying I forgot to put the argument here? Oh, so I forgot a couple of things here. So we didn't put the traffic light type here, and the traffic light type, and this will be current type, I think I'm also supposed to put what the argument is here. So this will be like current light. Is that what you were saying? Okay, thank you. We'll do this together. It's a collaborative project. The whole class working together. That's what, let's try that. Let's give that a try, moving the enum bind to the top. To be honest, I don't know why I put it down there anyway. Oh, that would actually make a lot of sense. So up here, it will set up the template stuff that it has to do to cast it to variant. And then down here, when GD virtual happens, that will already be registered. OK. I think that might be the thing. Closer. Oh, yeah, I forgot to... Or wait, no, OK, so show next light doesn't need any of this stuff. I was losing my mind when I was doing that. No, this can be void. It's the virtual method that has those arguments. This is fine. And then show next light. OK, there we go. Fourth time's a charm, perhaps? Yay. OK. So we're going to open up Godot again. Oop, I forgot to close Godot over here. And now we're going to attach a GDScript to our traffic light node. And we are going to implement that virtual function that we just created, get next light. You could see in the code completion, it knows about the types and the parameter name. And yeah, so we'll get the current light. We should be able to use the traffic light type as a normal type within GDScript. And yeah, we'll say if the current light equals traffic light type, I don't know why it has the colon in there. That's interesting. If it's stop, oh, something is wrong. I think we did something slightly wrong. I think in here we weren't supposed to put the name at the front of it. All right. We will turn it off and turn it back on again. Yes, so my plan was to talk about hot reloading when we got to the scripting part. Personally, when I'm working on like an extension to the engine, I don't use hot reload. But when I'm doing like game scripting, then I use the hot reload. But we certainly could. And I think it should work for everything that we're doing. Yeah, but we'll get to it in a little bit. All right, and if the traffic light type, there we go. If it is stop, then we will return traffic light go. Oh, and because yeah, we're extending the traffic light type, so we don't even need, or no, we do need to still put it. Never mind. I think that's just an autocomplete failure. Traffic light type, traffic light go. If the current light equals traffic light type go, then we return caution. And if the current light is caution, we return stop. Oh, and it's complaining that not all code paths return a value. Okay, by default, we're going to stop. And I noticed that I didn't put the... Okay, that seems correct. We're going to add a button. Put the label next light over here. Going to connect to the pressed signal. And we're going to call our traffic light, was it show next light? I don't know why the autocomplete's not working. Possibly because we're not using the type name. Or did we forget to bind that? We forgot to bind it. All right, one more step. Just close Godot. Run scans. Run Godot again. Let's see, show next light. Beautiful. This should work. Or not. I don't know why our ready function isn't working. It should be something by default, right? We have it set to stop. I mean, it's not that important that this class works perfectly, but I'm curious. Oh, switching programming languages too often. So this would have been perfectly good, like Golang, but yeah, we need case. That's probably why it wasn't working before when we first loaded in the editor and it wasn't actually showing the texture. So yeah, putting it without the case, I basically set a go-to label. C++ is silly. There we go. All right, and it's calling the virtual function on our GDScript to get the next light. Yes, and you can also have signals from your GDExtension class. We're going to add a simple signal, which is light changed, and it is going to give, I guess, whatever the new light is. And we will emit that signal when set light type runs and change the light type. So we'll do emit signal. So signals in C++ work a little bit like signals in Godot 3. You don't have the special like type objects you can use. You have to use connect and emit signal. So we're going to emit this light changed signal with the new type. I'm going to close Godot. I'm just going to close this VS Code window so it doesn't confuse me. All right, going to run scans. I think that should be everything we need to do to have this signal. Much less boilerplate. Just takes one. Close. Do we have to do like property info? Or, well, I just closed that VS Code window. Let's open it back up again. Okay, we do method info. All right. Like I said, I always just copy and paste these things from the Godot source code or from previous projects. It's verbose enough that it's hard to keep in your memory. So we do method info, light changed, and then property info. And property info has the type and the name. One more closing paren. Okay. So now we should be able to go to our traffic light. Our light change signal is here. And that will appear on our main script. We're just going to print it out. Print out what our new light is. Run that, hit next a bunch of times, and go look at the output. Oh, we still have the 7 left over from our summator, but here are the light types. All right. The last thing we are going to do with our traffic light example is we are going to make some documentation for it. So in the Godot editor, you have help information for all of the built-in classes. So you can go to like node and see its parent, what it's inherited by, a description, all of its different methods, and you can have those for your classes registered in GDExtension as well. So to do that, we need to run a command with Godot to generate, I guess, like the boilerplate of the XML that's used for Godot documentation. This XML format is the same format that's used internally within the engine. I wouldn't have chosen XML on purpose, but it's what's used in the engine. So the command we're going to run, I think I have it on the slides. I can copy and paste it that way. Oh, here we go. So Godot --doc tool, that would generate the XML for the normal Godot docs in whatever directory you tell it to generate them in. You have to run it with the Godot project. So we're going to run this in our Godot project directory, and we're going to say the directory above us, that's where I want you to put the docs. And I guess in this example, I was using path demo, which we don't need to do if we're in that directory. Let's forget about that. And then because we want it to do not the normal engine docs, but the GDExtension docs, we pass this argument. So let's do that. So I'm going to change directories into the demo project and run that command. And I forgot I don't actually have a command called Godot on my computer. I have a Godot 4 command. All right. And it runs and says it's putting the XML in this doc classes directory, which we can see in here somewhere. Doc classes. There we go. And it generated 2 XML files, one for our summator and one for our traffic light. And it has all of the things that we registered in code in here. So it'll have all of the properties, all of the methods, the signals and that stuff. It just doesn't have the human documentation to go with it. So you just fill that in. So we can say it's a traffic light for the description. That's the only change we're going to do, just for demonstration purposes. And then you can just run scans again. The template project already has everything set up to take whatever is in the doc classes directory and compile it into your GDExtension. So you don't need to do any other setup. You can see in here it is saying it generated this docdata.gen-cpp file that contains all of the information from those XML files. And if we run Godot again, we should be able to see our docs. What did I do wrong? Turn it off and turn it on again. There are frequently bugs with the documentation cache. There we go. It's a traffic light. Yeah, there's bugs with the documentation class even for native classes. So this is something that definitely needs to get fixed in Godot in general. But there is our documentation. All right, that concludes my traffic light example. How are we doing on time? So we're going to, from 9:30 to 11? Okay, yeah, so we have time. All right, we'll see if we can really quickly do this game scripting example. So we are going to create a very, very simple player controller. To do that, we're going to create a myplayer.h. Pragma once. It's going to descend from character body 2D, using namespace, Godot, class myplayer, character body 2D, our GD class macro, the class name and its parent class. And yeah, we'll have a variable for our speed, as frequently character controller examples have. we're going to have a constructor. We're going to implement physics process, which I think wants a double. And so when you're implementing any of these virtual methods within godot-cpp, godot-cpp generates like real C++ virtual methods that you can use, and it'll connect all that up for you. And let's, oh, of course we need a bind methods, even though we actually don't really need to put anything in it right now. Or I guess, yeah, we can put, we can have a property for speed. Yes? Yes. Yes, it would override it. If you attached a GDScript to this that had physics process, it would override it. But this use case, we're imagining that we're not doing our game logic in GDScript, we're doing it all in C++. Yes, exactly. And actually, like frequently when you're doing like an engine class, you would not use just notification physics process, you'd use like the internal version of that. There's like notification process internal, or maybe it's internal process. Anyway, there's another version that's frequently used within engine classes. Okay, I think that's everything we need. And we're going to implement all of these wonderful methods. All right, we'll do the getters and setters first because they are very easy. And I think I set a default in here. I did, so we don't need to do anything in the constructor necessarily. We will bind a property using the magic of copy and paste. And this one will be a float type. Speed, we don't need any property hint here. So that one's much simpler than the previous examples we were doing. All right, we have our speed property, and then we are going to implement our physics process. So to do that, we're going to get input. We need the input singleton. We'll store it in a variable so it's easy for us to get at. We do input : get singleton. All of the singletons work that way. You do the class name : get singleton to get the instance of it. And we will have a vector2, which stores our velocity. Really standard stuff. Input is action pressed, and we are going to use the UI actions, which I don't recommend doing in a real game. It's very commonly done in demos. We're doing it here for another reason, to allow me to show you guys how to register runtime classes, so classes that don't run in the editor. What's that? The questions about autoloads? So autoloads are different than singletons, despite in the like autoload configuration, there's like a singleton checkbox. But yes, you can, singletons are a little bit different, and you can register your own singletons within GDExtension that act just like engine singletons. You can also do autoloads, but it's done a little bit differently. So the way that you do that is you would create the class that you want to be your autoload in GDExtension, and then you would create a scene where that class is the root of the scene, and then you would add the autoload the same way that you usually do in project settings. You'd go there and select that scene to be the autoload, give it a name, all of that. All right, I'll try to do this very quickly. And copy and paste created some problems. And then we will set the normal velocity property on character body. In C++, there really aren't properties. That's not a thing. So if you want to set or get any of the usual Godot properties, they're done with setters and getters. So we'll set the velocity property on character body, and then we'll do move and slide. Oh, and I wanted to multiply this by our speed. So I think that is everything we need. Oh, delta. Or wait, no, we don't need delta for move and slide, right? It automatically takes delta into account. Yeah, if we're doing this in process, then yes, we would need delta. All right. Oh, we did forget one thing. We need to put this in register types. And my player. Okay, running scans now to rebuild it. Opening Godot. I'm going to put our character here, my player. We're going to have to add the usual stuff. We'll add a sprite to it. We will use the Godot icon because we will use the Godot icon, like all tutorials ever. And it wants to have a collision shape. And we'll just throw a rectangle on it. Doesn't really matter. We're not actually going to collide with anything. Let's run this. And I can press the arrow keys and move it. But you will also notice, if I use the arrow keys here, it will also move it in the editor, which is usually not what you want when you're doing game logic. So instead, we will register this class as a runtime class. And to do that, we use GDRegister runtime class. And let's close Godot. We probably could have set up hot reloading before this, but we'll do it after this. That's the next thing we'll do. So running scans to rebuild it. Running the Godot editor. And we'll run the game. And it still moves here. But when I come into the editor, pressing the arrow keys, no longer moves. If you're doing like an engine class and you want to have some things happen in the editor and some things not happen in the editor, you can wrap them in like an if statement that specifically, here, I'll show you what that looks like. You do like if engine get singleton is editor hint. And then you can have, like, these things will only run in the editor, and everything else will run in both the editor and the game. But if you're doing game logic, you basically want nothing to run in the editor, so we have runtime classes. All right, the last thing that I want to show you guys is hot reloading. So we will go to the .GDExtension file. Is it still called example? I meant to rename that. All right, and we're going to add an extra property in here, reloadable equals true. And we can't dynamically change it to reloadable. We will have to restart the editor for this. But we'll load it again in the editor with reloadable. And if we look at my player, the speed is at its default value, which is 100. Let's go into our player header here, myplayer.h. And we're going to change the default value to 200. And now put Godot in the background there, and then run scans again. And notice the editor is still running over here in this tab. Now I switch over here, and the speed is now 200. Reloaded, yay. All right, I have no idea how we're doing on time. I hear a lot of voices outside, so I think we might be getting close on time. But that is everything I had to show for you guys. Thanks for coming. So the question was, how can we export these to be loaded in another project? So you're imagining like you're making a Yeah, so in running scans here, we've done a build for Linux, a debug build for Linux. And you could copy the files that were built to any other Linux machine. It would run with a debug build with Linux. But if you are making like a reusable GDExtension that you want lots of other people to use, you'll probably have to do a debug build, a release build. You have to do a Windows build, a Mac OS build, and all of that. But if you can build those, basically everything that ends up in the bin directory. So we have this bin directory here, which has the example.GDExtension, which you should definitely rename to something that's not example. And then these different directories that are meant to hold the builds for all the different platforms. We only did Linux debug here, but you could copy this bin directory to any other machine. GDExtensions don't need to be under the add-ons directory like GDScript add-ons need to be. You can put them anywhere in your project, and Godot will find it. So the question was, from C#, can you also access the GDExtension that you make? Unfortunately, right now, the story with C# isn't great. You can access it, but essentially like through using reflection. It doesn't generate a nice C# class for you that you can use. There's a community project that made like a generator to generate C# classes, which then do the reflection for you. But yeah, this is an area that we really need to improve. I don't know if we're going to improve it with the current iteration of C#. You may know that there's work going on to move C# to GDExtension, and just the general idea of allowing one GDExtension to use classes from another, to extend classes from another GDExtension, and we're working on that. I have a feeling this problem will be solved with C# moving to GDExtension. It's certainly possible to solve with the current thing, but I don't know. There's limited contributor time, but yeah, we're working on it. So the question was, are there ways to have the GDExtension only be exported for certain platforms or with certain feature tags? So there's a couple of ways to do it. Right now, there's at least one way that's missing that I would like to add in the future. But the ways that exist right now is if you have in your GDExtension file, your .GDExtension file, if a platform isn't listed, then it won't get exported. You will get an error, but the export will succeed. Like it will succeed. So if you want to, for example, on desktop platforms, you want to use the WebRTC extension, but then on the web, you don't want to use it because it's not needed. You just don't have web in there, and it won't export anything there. That's not great because of the error, but it works. Also, on the subject of just like random feature tags, each of the things here are feature tags. So these values aren't magical in any way. It's basically saying if you have the feature tag Linux, the feature tag release, and the feature tag RV64, select this one. You can put any feature tag in here, even ones that you make up like custom feature tags for a particular export preset. And so you can use the same technique by just having the binary listed for that particular feature tag. But again, you'll get like that. I guess it's not an error because it still works. So you'll get that warning about it not being found. Another way that requires more work is you can make a editor export plugin that decides dynamically during export time to include or not include a particular file based on whatever you want, whatever programming logic. And you can create an editor export plugin either in GDScript or in GDExtension. That's more advanced. What I want to add in the future is the ability to enable and disable GDExtensions in general. Like right now, the way it works is if the GDExtension file's in your project, it's enabled. It would be really nice to have the ability to disable them. I would like to do that with project settings. And project settings are able to also have feature tags. So you could say, enabled dot, I don't know, ARM64, and then uncheck it, and then it's not enabled on ARM64. But that's not something that exists yet.